Have you ever wondered how to fetch data only once when your component loads? Well, let me walk you through a simple example. We use a hook called useEffect. Inside, we fetch data from an API, then process the response to JSON, and finally update our component's state with this data. To make sure this happens just once, right after the component mounts, we set an empty dependency array. This way, our component stays updated without unnecessary API calls. Imagine you're signing up for updates from a chat service that sends new messages to your screen. You use useEffect to subscribe to the service when your component mounts. The magic here is returning a cleanup function that unsubscribes when the component unmounts, ensuring resources are freed up and you're not getting messages from a chat you left. It's like telling the service, "Hey, I am out, stop sending updates." Imagine you've got this digital counter that keeps track of how many times you've clicked a button. Each click is like a mini celebration. Now, to keep this party alive and share every click, we use something called useEffect in React. It's like a vigilant watchman, only springing into action when the count changes. So, with every click, it broadcasts your new click count, making sure everyone knows how many times you've celebrated. Imagine you're trying to update a user's age in your app continuously but accidentally trigger a non-stop party where the app keeps adding a year to the user's age every millisecond without end. Here's the trap. By tying the update directly to the user's current age, and including that age itself as a trigger, we create an endless cycle of updates. It's like telling a stopwatch to keep resetting itself every time it ticks. Chaos ensues. In this piece of code, we're diving into the chatroom component. We're using the useEffect hook to periodically fetch the latest message for a chat room. To optimize performance and prevent unnecessary re-renders, we wrap our message fetching function in useCallback, ensuring it only changes when room ID does. Thus, our effect only re-runs when absolutely necessary, keeping our app snappy and efficient. In our next discussion, let's tackle useLayoutEffect and why it's a game changer for visual updates. Imagine you want to capture an element's height and display it without any awkward flickers on your screen. By using useLayoutEffect, you ensure these measurements and updates happen smoothly, right before the browser gets a chance to paint. It's like preparing your canvas perfectly before the first stroke of paint, guaranteeing a seamless visual experience. Hey, so imagine you're building a component that displays a user's profile. You have the user ID as a prop and you want to fetch the user's data whenever that ID changes, right? Here's how you do it. Use useEffect to trigger a data fetch whenever the user ID changes. By including user ID in the dependency array, it tells React to rerun the effect, fetching and displaying the new user's information. It's like an auto-update feature for user profiles. In React's strict mode, effects run twice as a development aid, mimicking a component's mount and unmount to check the cleanup logic. This is deliberate to ensure cleanup mirrors setup actions, reducing bugs. For example, in our component, when we increment the counter, the effect logs its setup and cleanup, demonstrating how strict mode can help verify our cleanup without affecting the production build. It's like having a safety net, catching issues early in development. In this code snippet, we see how crucial cleanup functions are when dealing with listeners like the window resize event. Initially, the effect sets up a listener that logs a message whenever the window is resized. To avoid memory leaks, a cleanup function is provided to remove the listener when the component unmounts. By doing this, we ensure our app remains efficient and responds only when it's necessary, keeping our resources in check. Imagine a timer that constantly updates every second. We're using a cool trick where we store the current value of our counter in a special variable called a ref. Even though the main counter updates on a set schedule, we keep track of its latest value with this ref. This clever setup allows us to keep incrementing the timer without needing to re-establish our code's conditions every time. So, we get a smooth, constantly updating timer that always knows the correct time.